Hey everybody, welcome to Rackspace, the #1 managed cloud company. This is Office Hours, our weekly live panel discussion show where we talk about the cloud and the technology that runs the cloud. My name's Alan Bush. We're broadcasting from the Castle, Rackspace's headquarters here in San Antonio, Texas. I've got a couple of rackers with me here today to discuss cloud images. So we're going to be talking about the way that our cloud servers you can save images, you can build from images, you can orchestrate from images, you can do all types of stuff with images. We're going to talk all about that. I've got them with me here. I've got Reese Mcjunkin with me and Russell Troxel with me. And then live from his home studio is Drew Cox. For those of you that are watching on Facebook and Periscope, hey everybody. Hey Drew, how you doing?
Doing well.
That's the voice that you hear. That's Drew's voice right there. You can't see him. If you want to see Drew, if you want to see everything that's going on, head over to live.ohpodcast.com. That's where you can check us out and see everybody. But wherever you're watching, I encourage you to ask your questions. If you have any questions at all, let us know. We brought in all the experts to talk about this, so we really want to hear those questions and answer them for you. But yeah, we're going to be talking about images today. So let's go ahead and jump into that. First, I want to introduce you guys. Reese, why don't you go ahead and introduce yourself? Tell us a little bit about what you do here and how long you've been a racker, all that fun stuff.
Sure thing. Howdy, everyone. So I've been going on Racker almost 5 years now in September. Entire time I've really been in our public cloud department. So really just kind of been involved with our public cloud since beginning to really to where it is now. And then I guess the title I'm the support specialist.
I think you're a Linux systems engineer or something like that. Yeah, but what does that mean? I mean, like you actually help our cloud rackers make the cloud run, right?
Yeah, it's kind of just a fancy title for a technical leader. So really what I do is I just work with the front-end support teams who work with the back-end engineers and developers and take the customer feedback, figure out the issues, and try and get those issues resolved.
Yeah, just that.
Yeah, just fix the problems.
Just a couple of things.
Make things work.
Great. And then Russell, tell us a little bit about yourself.
So I'm Russell Troxel. I'm a cloud virtualization engineer. That's one of those fun technical people that Reese messes with all day. I've been at Rackspace a little over 2 years now, as of May, and yeah, that's about it. I do all of the fun things that Reese does, work with our product teams, work with our customers to make sure that everything runs the way it's supposed to.
Yeah, and I just want to give you a little quick congratulations for being awarded the Fanatical jacket last week, and then you, Reese, for last year, I think now. Yeah, about a year, yeah. So congratulations on that one. So that's, if you're not familiar, that's kind of our top-tier award for going above and beyond here at Rackspace. So yeah, we definitely brought in the experts for this one, and you guys have certainly earned those distinctions. All right, so hey, we're going to talk a little bit about cloud images, and I think one of the things we wanted to talk about, it's a bit of a point of confusion, I think, for some people, the difference between cloud images and cloud backup, right? And I think that there's some confusion where people kind of want to use them together. They kind of want to use one instead of the other. So what are some of those best practices that you might want to use when using cloud images in a backup context?
Well, I could jump in that real quick to take it at a high level, and then we can start drilling into it a little bit.
Yeah.
So really at the highest level, cloud imaging is really just to take a high-level snapshot of your server itself, and then whenever you actually take that snapshot of the server, it's more of a massive copy of the entire hard drive itself. So it's kind of a longer, full backup that you're actually taking of the server. And since we're taking that image of basically the entire block device itself, it actually takes a little bit of time for it to process, us get that image compressed, and then kind of send it off to where we're storing that. And right now we're storing those images in cloud files. So there's a little bit of stuff that kind of goes on in the background with that. So that's kind of like high level what the cloud server image is, where really we just go in and image the entire hard drive itself.
Right.
Versus the cloud backup agent is an actual agent that runs inside of the server that's a file level backup. So with that one, you actually get to go and tell, like, I specifically want to back up this file, these directories, and actually go through and do it at the file level versus the block level, which is the entire hard drive itself. So at a high level, that's kind of what cloud imaging is itself, is really just kind of imaging that virtual hard drive that's associated with your server. And on different types of cloud servers, that presents in different ways, right? Because what the general purpose servers have a separate system OS drive and a data drive, right?
No, not anymore. The old performance servers were that way. The new general purpose servers, we consolidated everything. Okay. I mean, there were a couple of reasons for that. The big one was Windows servers. We were noticing that when we had that data disk, that 40 gigabyte system disk was not always enough to hold what we needed to be on the C volume for Windows, and that's why we made that change.
Yeah, and so with that though, now it means that you are potentially, like you said, backing up the entire thing, and that could be hundreds of gigabytes, right?
Yes.
And then because of the way that the backups work, I mean, that can start to compound, right?
Yes.
Yep. Yeah.
Yeah. So what Alan's talking about a little bit there is the differencing VHD system, which is a big technical term that we use in Zen Server. What differencing VHDs basically are is you've got little static files that we use to represent hard disks. So inside that file, you actually have a full block level file system. The reason we call them differencing is because we have a chain of them. So basically, we have one file system, one VHD that's sitting there read-only that has all of the base data for your hard disk.
Okay.
And then we keep one separate one, a little one that's much, much smaller that we write all of your changes to. And the cool things about that is it lets us do things like cloud images, like migrations, like resizes without having to turn you off the whole time, because we can copy that read-only data without having to worry about you making changes. The problem with that is that because you have those separate disks, you can actually be storing some data in multiple locations, because that original read-only copy is going to store a lot of that stuff that has since changed. So when you are to actually back that up, you may be backing up significantly more data than you actually think you have on your file system. So in that way, that's kind of the positive of cloud backup over cloud images, is if you're using this as a incremental backup, cloud backup will actually let you deduplicate files. It'll let you take just incremental point in time small bits of data that have changed since the last time you've backed up, whereas images, you're going to be backing up the whole thing every time you image.
Right, and that's really not what you don't want to do that most of the time, right? You want to have that single, you want to have like individual files, because you might have, depending on how your application is set up, you might only have one or two files that change at all, and so it's completely wasteful to go ahead and back up the entire image for that, right?
Well, I mean, and the other piece of that is that it's using the same storage backend. Both images and cloud backup are both backing up to cloud files. So all you're really doing by taking images every single day is paying extra for the same data, because you're paying for the whole file system from every single day.
I see. Yeah, you don't want to do that.
No. And then the other thing I kind of want to throw in there too is with the VHDs that Russell was mentioning, there's a little bit of limitation and caveats in our environment too with that. We get a lot of questions around like, all right, well, my server only has 20 gigs of data on there, but I look at my image is 300 gigs worth of data. Right. So there's a little bit of issues that kind of go on with the VHDs themselves. With VHDs, unfortunately, the way that we have them set up right now is they only grow in size. Okay. So if you have a server, you throw 300 gigs of data on that server, you take an image of that server, it's going to be 300 gigs. You delete 280 gigs and you image that server again, it's still going to be a 300 gig image on the back end. So by you blowing up that VHD once and forever going forward, that image is going to be much larger versus the cloud backup side of that one too.
Great. Yeah, and to be clear, that's not really a limitation of our environment. That's part of the actual VHD format. Right. Because it is a block level device, right? We're taking one file that represents your entire block file system. As soon as you write that file, it is no longer a zero, which means we have to save it regardless of whether or not you delete it later. We have to save it because we can't tell whether or not there's actually a file there or whether or not it's just a pointer.
We don't like to randomly delete things on virtual hard drives. No, that bit, you don't need that bit. We can take that bit out.
Yeah, that's a good practice.
Well, and when you're using an image, you're also you're capturing that OS, and we do a great job of maintaining images with that OS on them that you can build from new. So you don't need to copy all of this redundant stuff that you can easily rebuild. You don't need to copy all of the stuff that may not be terribly important to your ongoing business. And with Cloud Backup, you can very efficiently do that without any of the concern or headache around, what am I doing to impact the VHD? What am I doing to impact my flexibility? How can I get the most out of this? And that's really where this conversation becomes valuable, is how do you get the most out of the tools at your disposal? Because backup is a huge and important process to go through. You need to be sure that the data that's crucial to your business is safe and probably in more than one place. However, you also need to do things like be ready to stand the environment back up in case of an emergency or a reason that you may have a forensic process you need to go through, and you need to have a second environment that you can work through, or just through your development process, having multiple identical environments. That's the other important consideration. And I think a lot of times Those two get blurred when you introduce a tool like Images, because I think people just look at it like, oh, it just copies everything. I need a copy of everything. We're good. And then the water gets continually muddied when you start talking about boot from volume and our block storage offerings and how you can interact with them. So why don't we go ahead and clarify the block storage situation? Let's get that out there and define some terms, and then maybe we can talk about some of the other components involved.
All right, so block storage, let's talk about it.
Oh boy, so block storage. We'll get into that a little bit. So with block storage, what that is basically, with all of our cloud servers, we offer additional storage through our Cinder product, which is basically just a external hard drive you can plug into your server.
Yeah, that's a really good analogy.
In your control panel, that'll be labeled cloud block storage.
Yes, cloud block storage is how we kind of have that one out there. What's nice about that is it will, you can use it as a external hard drive just to expand the storage memory or the boot partition for the server itself.
Yeah, so some of our workload optimized servers, for example, they all boot from that block storage volume. They don't have an internal system disk on them.
Exactly correct. So whenever we actually use the CBS devices, the cloud block storage, as the backend for the root partition, it actually changes up our imaging process. So it is actually a completely different imaging process than it is for a typical cloud server. Whenever you have the typical cloud server, so we can actually do some shenanigans with the VHDs, imaging it, and sending that image off to cloud files.
Right.
On the cloud block storage side, it's a little bit different in how we kind of take those snapshots itself. It's not done with the VHDs, it's a little bit different technology over there. But at the end of the day, it is still a snapshot of the CBS device, but whenever you take it of those CBS devices, it can only be restored on those CBS devices itself. They don't really play too nicely. You can't take a CBS snapshot and then build a regular general purpose server from it.
Right.
You can go the other way sometimes, going from a general purpose to boot from volume, but not boot from volume to a not boot from volume right now. So there are kind of those limitations in the system itself right now.
So what are some of the big benefits to using block storage? Like, what are some of the big use cases that are the most beneficial to customers for block storage?
One of the best use cases for block storage itself is, unfortunately, the cloud runs on hardware. Sometimes that hardware itself will fail. And when that hardware itself will, it's usually on our cloud server side and not on our the CBS side. So let's say if you have a cloud server that's backed by a CBS device itself, if we have a failure on the Nova side, you can actually delete that server and rebuild it with the exact same data set you had before into a new server. It would, however, get a new IP, but you can recover it within seconds.
But that that data doesn't change.
Exactly,
because the
it does not change at
server
all.
had an issue with
the only thing that's going to change is basically the IP address assigned to that server, because all it's going to do is basically rebuild your server from this server over here to another server over here, exactly the same data set, just a new IP. So that's one of the main advantages of using a CBS back server itself, is in that kind of data recovery situation. Much easier. And there's also some cool functionality too with cloning CBS devices. If you use a CBS device, you can actually clone it off and spin up a secondary server from there, and it actually will bypass all of our other means. So if you clone a CBS device, it's going to go straight from one CBS host to another CBS host. So you don't have to worry about using our cloud files as a middleman, take an image, send that image to cloud files, and downloading it back to the host. So it's just kind of a way to also eliminate a little middleman and help kind of get you to that cloud environment, cloud happy.
Well, that's really what we want to kind of share on this program, is kind of how to get to that cloud happy. I like that cloud happy environment. So that's good.
That's a technical term, by the way.
It is. It's very technical.
We just coined that.
Yeah. So somebody get to the patent office. So yeah.
Well, one of the terms, or a couple of the terms you've been using, are OpenStack terms. And just to be clear, our cloud is built on OpenStack. So when we bring up words like Cinder or Nova, those are all OpenStack projects on which we've built OpenCloud, Rackspace public cloud products. And so when you're leveraging our cloud, you're leveraging an OpenStack-based public cloud. And so all of these terms may sound very familiar if you're familiar with OpenStack, or you may be familiar with our public cloud and not know all of this terminology. So there are dots to connect between these two worlds, since they're built on top of each other. A lot of this terminology that we use commonly here at Rackspace to represent things that the cloud knows. Yeah, it's a compute instance. Okay. Great. That's a block storage instance. Okay, that makes sense. But when you start referring to them in other terms and with our terminology, just know that there is a glossary. We can put that in the show notes, so you can kind of connect the dots between what Projects OpenStack has brought forward and what we have built products on top of as Rackspace.
That's a good point. Yeah, I mean, we've built all on top of OpenStack. We're one of the major contributors to OpenStack and one of the founders of it as well. So we have enough faith in it to build our own public cloud on it. So
a little bit of skin in the game.
Yeah, just a little bit. Hey, I just want to take a real quick second to welcome everybody that's watching live on YouTube, on Facebook, or on Periscope. This is Rackspace, the #1 managed cloud company. It's our weekly live broadcast called It's where we're experts and we talk about cloud topics. And today we're talking about cloud images, kind of the different ways that we can use them, some of the do's and don'ts, and some of the best practices that are out there for them. I want to invite anybody that's watching along, either right now live on Periscope or Facebook or YouTube, or in the future. Let us know. Let us hear from you. We'd love to hear from you. If you're watching live, we can answer your questions in real time.
I love answering questions, guys. Send them on in.
Reese is very good at answering questions, and Russell's not too shabby himself. Ask us questions. There's a couple of ways you can do that. If you're watching on a place that has comments, comment. Right? We can get them. If you are watching in the future, I'd love to know how the 4th of July weekend went. Let me know about that. But also, you can just send us a comment wherever you see it down the road, and we'll go ahead and try to answer those questions in the future, wherever it is. So I would love to hear from you there. Love to hear from you. All right, so let's talk some of the other considerations about images. And, I think a lot of people we've talked before about, it's not the best idea to use cloud images as your entire backup solution, right? You don't want to just, image the entire system and then try to reboot, in a couple of different cases, right? So some of those cases might be there is a host machine that goes down, right? We've talked about that, right? The cloud servers are a little bit ephemeral, but they're actually on physical hardware. You can go and you can touch the hypervisor that not you, but the people in the data center can. But it's out there, so it's physical hardware, and the problem with any physical hardware is it's going to break, right?
Eventually,
over enough timeline, right? So that's the thing. So it might go down, or you might just be expanding your application, right? So you might be taking our advice and scaling that application out horizontally with multiple servers. You might want to start with a base image from that. So let's talk about some of the considerations when you are expanding out and using expanding out that way. Right?
Yeah, so there's a couple different ways to expand, right? Especially lately. When we first built cloud, there were not the wonderful tools that we have now. I mean, we had Puppet and Chef, but Ansible, Salt, all of those wonderful tools were not what they are today.
No.
At that time, images were really the best way to orchestrate. You would build out your base environment and you would image it, and when you were ready to spin up more servers, you would use that image, spin up, and do whatever you needed to do to restore your newest data. At the time, we were recommended cloud backup, but there are lots of solutions to do that. There are still good reasons to use cloud images. Vein. It's a good starting point, especially when, as Alan mentioned, we do have hardware failure. Everyone has hardware failure. We love to talk about our 4 nines of uptime, but occasionally you will see that there's going to be downtime. And when there's downtime, those images make it very, very easy for you to get back up quickly, because you can use that image, spin up your base environment, go out and grab your cloud backup, restore any web data that's changed, and you're back on your feet and running. As far as deployments, it is great for small deployments where you may not necessarily want to be maintaining an Ansible Bastion or a SaltMaster or something like that. Images are great to spin out your 2 and 3 node clusters. Anything larger than that, SaltStack and Ansible are probably going to be a better bet for a couple reasons. Our base images are actually cached on all of our hypervisors. We have some really cool technology that we use called fast copy, where we actually take all of those images, cast them on hypervisors as VHDs, which we learned about a little bit earlier, which lets us, when you build a server, we're not doing any data copying. We can now just add a new child VHD to that base copy image, and you're up and running with no data transfer, which means that server can spin up in sometimes under 30 seconds. And then your SaltMaster takes over, or Ansible, or whatever you normally use. Make sure it's configured and you're quickly up and running with very little intervention.
You kind of mentioned the time that it takes to spin up, and I think there's a couple of different factors there. You guys want to go into some of those factors? I mean, I know that there's some caching involved. There's a whole bunch of different factors that go into the time that it takes to spin up a new image.
Yeah. So if you're using the base image, kind of what Russell was pointing out there, it's going to be great. Your provisioning time should be sub 60 seconds. Generally, your server will be active and pinging within 15 to 30 seconds off those base images due to that fast caching benefit. But when you start getting into the custom image territory, that's where it starts to get real kind of great, because it all completely depends on not how much data you had inside the server, but how much data you had in the server at one time.
Okay.
Because this kind of goes back to the VHDs. They only grow, they do not shrink in size. So that master server you set up, if you originally set that server up, downloaded a couple hundred gigs of data to it, and then cleaned it all off and you got it back down to 20 gigs, on the back end, that image is still going to be a couple hundred gigs because that VHD blew back up. And that's where that process can kind of slow back down. So if your image does grow to be somewhat larger like that and you need to build out quickly, it's going to take time, because we're transferring 10, 20, 100, 200, even up to terabytes of data to those hypervisors to actually build out those servers. So that's why we always recommend going to the automation route. Use those base images. We have a team dedicated to pushing out these base images. When security advisories come out, other stuff comes out that's basically this is bad for these servers, we push up updated base images to counteract these security threats like that.
And the other part of that is, I mean, that's a worst case scenario, right?
Yeah,
like when you have 200 gigs, 300 gigs, it's obviously going to take a long time because we have to download that data out of images. But even if you're talking about just your golden image, like we discussed a little bit earlier, even a base Linux operating system is probably going to be 4 to 5 gigabytes of data. That's not a lot, but it's still going to actually have download time associated with it. So when you go to build that server, you're going to be looking at least probably 10 minutes or so before it downloads, where instead of the 12 to 30 seconds we were talking about. So since you're going to have to orchestrate after that anyway to get your dynamic data into the device, it's probably safer for you to go ahead and use a base image and orchestrate from there. I'm sure a lot of you are thinking, how do I do that? How do I get it? I'm going to have to log in through SSH or something like that. There's a couple different ways to do that. There's orchestration, also known as Heat. Orchestration is what you'll see in your control panel. Heat is the OpenStack product. Will let you spin up servers and use it's Chef Solo, right? That's using to actually provision them
about
from there.
15, 20 different templates that are out there. That's just in the control panel. Then on top of it, since it is a Heat product, there's a ton of different templates out there in the OpenStack community itself. They're all completely
And then you can make
open.
your own as well.
Exactly. So it's really easy to take those and kind of grow onto them.
Yeah, and on top of that, we have another piece of technology that's in all of our images called Cloud-init. It's a Canonical product. That's the makers of Ubuntu, which will let you do that at a cloud server level. So you outside of Heat, you can pass a cloud config drive and let it spin up. I actually use this quite a bit because Cloud-init lets me kick off a Salt minion, which will then check into the master and
Salt minion, you say? What exactly is a Salt minion?
So I'm sure many of you already are familiar with SaltStack, but SaltStack is a config management system, and SaltStack has two big concepts. It has a Salt master and a Salt minion. They communicate via 0MQ for those who care, but what that allows them to do is when a minion comes up, when it registers with the master, it can just send out a command to the master and say, "Hey, what am I supposed to look like?"
Yeah.
And, the
this is what I look like. What am I supposed to look like?
I'm an adult. What do I do now?
Right. and the master says, "Well, you poor little minion guy. These are the things that all your friends are doing. Maybe you should do those too." And then you can there's all kinds of fun orchestration you can do with that lets you automate all the things, which is what we love to do in cloud.
So one thing that you might have heard before is we like to tell customers not to have their servers in a pet mindset and more of a cattle mindset.
Yeah.
So this kind of goes back to that itself. Like anyone.
Real quick, what's this pets versus cattle mindset?
So pet versus cattle. So a pet, you're like, oh, look, I have this nice little dog, this puppy, it's so cute. I don't want it to go anywhere. I want to cherish it forever and never let it go away. That's fine for dedicated servers, stuff that sticks around for a while, but not for cloud. Cloud is meant to be very ephemeral, have an issue, blow it away, and recreate itself. So in an ideal world in your cloud environment, you should never really treat the servers as a little baby or anything. It really should just be cattle, really just farm animals. Like you should never really care too much about it. If it has issues, send it out to the pasture and move on, get another one. And that's really how you should kind of be treated. And Salt and all these other automation technologies help you kind of get there to that point.
Great.
Yeah, the big term we have in the industry is immutable infrastructure, right? It's the concept of having infrastructure is separate from your environment. Infrastructure is separate from your environment. So you have some sort of system that takes this is what things should look like, and puts it on your server, so the infrastructure is not held up and tied up.
There you go. You mentioned some of the we're kind of starting to talk about that orchestration, that configuration management layer, and it seems like we're kind of moving toward this idea of let's use some combination of cloud backup, cloud images, and some type of orchestration layer to put all of this together if you need to build from scratch, if you need to restore in the event of a backup or a hardware failure, if you need to expand your application. I mean, so let's talk about some of the more of the ways that you would do that. What are some of the best practices that you would use if you're using some type of orchestration service?
Really, I mean, at the end of the day, the more the better. Like, the more backups you have, the more automation, the more kind of systems you have that kind of play nice to each other, it kind of helps out. But there is a level where it starts getting a little bit more complex than kind of what you want to do. But multiple backup systems, we always recommend. Cloud imaging is good to kind of do, but it's not good to rely on. Because one thing we haven't really hit on too much is once you take the image of your server, it's not... you don't know for sure it's going to boot because all we're doing is taking that block level of that server itself. So if you go down the cloud imaging route, it's going to work for some scenarios, but not all scenarios. And that's kind of where that cloud backup portion comes in to kind of give you that overlap where you have that kind of safety blanket where, like, okay, well, my image didn't work. Well, nice, I have my cloud backup I can restore to too. And then from there, it's really tied into the automation itself. If you go down the way with the Salt automation, it's really great because that's kind of you stand up the node itself, it checks in the node, and it starts pushing out a lot more jobs versus Ansible. It's more you telling stuff to do.
And the coolest part is you can put your entire infrastructure in Git,
yes.
right? Like it's all flat static configuration.
If you're not using Git, you need to use Git. It's so good, guys.
And so let's talk about that too. I mean, as security-wise, I mean, you don't necessarily want to pass any type of secrets through through a public repository. So you can do that through a private repository, right? Or use Cloud-init, right?
Yep. Or and on top of that, pretty much every major configuration management system has some way to specify secrets outside of your main configuration. So in Salt, that's pillars. You have separate pillar files that you put all your secrets in. And Ansible, that's group variables. You can just exclude that single file with the credentials from your repository. But there's lots of ways to do that to make sure that your secrets are secret.
Yeah, exactly.
Which is why we call them secrets.
well, there you go. Well, yeah, and that's something to absolutely keep in mind is double check, make sure that your secrets are being kept secret, so that you can keep your infrastructure safe and sound.
Yeah, both of you really touched on some of these things that we hit on every week. Verifying that what you have in place really does what you expect it to do. Having an image that you intend to use down the road that you haven't actually built from and verified it gets you where you want to go. It's a really bad day if you're under duress and you need that image to work right now. You've not tested it and it doesn't function the way you expected. So to have a process in place where you verify that that image is going to get me everything I need. It's got everything I need on it. It boots. It's a useful tool for me. I know about how long it's going to take to be ready to go is a pretty huge deal. Always good to ensure that your secrets are still secret. But a lot of these things come down to planning, and you can have a plan all you want, but if you haven't tested your plan, it's just a hunch. And so as things get more complex, as you start bringing in all these different components, it's really good to verify as you make a big step towards a more automated or adding a new feature or adding a new tool to your tool set, that it plays nicely with all of your other tools, that you get where you want to go using those components. And images is one of those situations where if you're relying on it heavily, verify that when you rely on it, it's going to do exactly what you expect, because it would be a terrible day to say, yeah, I've got this image. I've seen images come up in 30 seconds, so I don't really need that long before I'm up and running. And then you go to build from that image, and it takes 5 minutes instead of 30 seconds. And then your automation doesn't get a chance to run because it timed out. And there's the snowball effect that if you'd have done it in a quiet moment when it wasn't crazy and you weren't under duress, there wasn't a situation where maybe you had a lot of traffic that you really wanted to handle, an opportunity for the business to do well, or something else. You don't want that situation to be the situation in which you find out that it doesn't act as expected. So a beautiful thing about the cloud is it really doesn't take much time or energy or cost to verify, yeah, that image spins up. It spins up in about this amount of time. I'm going to I'm going to poke around, make sure everything is there that I need, and then I'm going to delete it. Okay. You really can do that very effectively, very little time, very little cost, and it'll pay huge dividends down the road if you did uncover something that wasn't ideal and you fix it before that situation when you needed to rely on it. So I think there's a lot of comment around this subject of verification and be sure, but it really does take planning to run these test drives, run these fire drills, verify. I mean, you have to do the work to really have something you can lean on instead of just crossing your fingers, because if you cross your fingers and it doesn't come out, that's a bad day.
Yeah, no, I just want to reiterate that too, Drew. Like, 100% agree with you on that. Any image you have, if you have not verified it, is not a valid image, just flat out. Or any backup, I want to say, not just image itself. And then on top of that, really running through those different scenarios, high traffic events, downtime event, losing a node, losing a DNS node, just all those different kind of events that come up. Those are great little scenarios to run through just throughout the day. And like you said, it's the cloud. Throw stuff at it, delete it right away. The whole process the whole idea is really just to run through the process, get comfortable with it, so whenever it is D-Day and you're in it in those hard downtime situations, you have a plan that you know works, you've done before, and you can kind of knock it out in this quick time frame.
Yeah, and I just wanted to talk a little bit about those situations where those images aren't good, right? Like we talk a lot about those images not being good. It's not because the process of imaging is broken, right? The reason that images aren't good goes back to that snapshot in time. Especially, we all use dynamic data, and when we use dynamic data, we use databases. When you write to a database, we have open file handlers. When you take a snapshot in time of a file system and you have an open file handler, you have even odds that that file handler may not show up in that image because it may not yet have been synced to disk.
Right.
And that happens across your entire file system, right? There are system files, there are all types of files that have open file handlers at any particular point in time. So you really need to make sure that you verify those images, make sure that all the files that you expect to be there are there in that image, so that when you boot up from it, you don't get any surprises.
Yeah, and then the area that we see this most impacting is servers that have been online for a prolonged period of time that haven't had routine reboots or updates done to it. And it kind of compounds the fact that Russ was talking about there, the open file handlers and stuff like that. The longer the server's been online without being rebooted, without having its packages updated and stuff like that, the more we see a higher chance of issues kind of coming up with that image when you go through to try and boot it up. Like, okay, well, it didn't fully boot because it has like 4 bad inodes. Got to go through and do a fisk on it real quick, or something else kind of along those lines.
Well, and you know, you mentioned like you have a server that's running a database, right? And you have, this is one of the reasons that we coach people to have a distributed architecture, right? Where you have a server running the database, and then you have multiple servers that are running the web tier, so that you can do the backup differently for each of those different tiers, right? Because I mean, in theory, depending on your application, you could have a very simple web server that doesn't need any data, right? You could be pulling data from a different server, touching that database to put everything together, and then sending all of that information back to the web server to then be, you know, displayed on the web page, right? And each of those different components will have different requirements for backup and for images and for orchestration. You work them all together in the right way, and you can really start to use that better. So it kind of all goes back to that same thing there. Let's see.
Yeah, I think that really speaks to the one-size-fits-all mentality that sometimes is brought to a situation like this. There's a solution that has worked in the past in one process, and it just assumed that will continue to work in broader and broader circumstances. And it's really convenient when I want to buy a new hat and I just see a one-size-fits-all option. I just order that one. Right. But there's some. It may not fit perfectly, but it's not hard. If I want to get a suit, I have to go get it like fit and trimmed, and they have to do all sorts of measurements and then refittings and all sorts of stuff. But at the end of the day, I know I'm getting something that's perfectly tailored to my needs. And so as a project moves forward and as requirements change, it's really important to look back and say, okay, it was one size fits all when I only had one thing I was really trying to do. But as my requirements expanded and as I needed more, it got more complicated. And so now I want to tailor my approach a little bit more specifically for these different, in your example, like the web tier. Let's rethink how we're approaching our web tier. It may not be appropriate if we're approaching it in the same way that we did when we had one server doing all of the things. How can we be more efficient? How can we get more out of less? How can we approach this in a way that may change our mindset a little bit, but we'll reap some rewards. And so complexity makes things a little bit more difficult in some ways, but you always want to be reaping those rewards as you go. And if you keep in the lane you started in, a lot of times as technology grows, Russell brought this up very early on. Puppet and Chef were there years ago, but now we've got Ansible and Salt and these new tools that kind of broaden the playing field and make things a little bit easier to pick up, and tools that are massively useful if you spend a little bit of time to begin to integrate them, that you wouldn't have had, and just logging into every server and doing that pets mentality of treating dedicated servers the way we've treated them historically isn't the ideal any longer. If your complexity is expanded into the cloud and you're using these some of these tools and not all of them. So really important to continue thinking through how you can take advantage of these various options and get the most out of them. It's a prioritization conversation.
And one thing I want to add on that too is don't feel scared by all the different technologies out there, especially if you're in the cloud space itself, because cloud space, regardless in the industry, it's changing at an extremely fast pace. And with that, we have new technologies coming out all the time. And with that, there's this really cool stuff that comes out with it that should just kind of help you maintain the environment, just really make your everyday sysadmin life so much easier in the cloud world itself if you actually just take the time, play around with the technologies, and start implementing them.
And if one's daunting, there are so many different answers, right? There's no one right answer to how to keep your infrastructure up to date.
Yes.
Exactly. And you can call us.
Exactly. Yeah, that's what we're here for.
Right. Yeah, I mean, that's what we're here for. And
this is a 1 hour show where we have cameras and microphones on us. For the rest of the week, we do the same thing. We just do it with a phone to our ear and tickets at our fingertips. And so we're having these kinds of conversations with customers all the time. How can you solve this specific pain point? How can you get more value out of this specific product? And how can we resolve this specific issue? That's what we do every day. And so if you have a situation where you're like, I let that whole orchestration thing get a little bit out of hand, and I haven't really caught up to speed, can you point me in the direction of a couple things? How can I get started? You can have a really a one-on-one conversation with somebody who knows what they're talking about by calling into Rackspace, because we're a company full of learners who are passionate about technology, who are passionate about helping customers succeed. And so we've got a lot of expertise that is available far beyond just a weekly show for an hour. For the whole week, we're on calls and with customers talking about how to do this. And so bring your specific situation or question or end state to us, and let us talk about how to get from point A to point B and how to make your approach more valuable to your business. And that's one of the things that we do that we really enjoy. That's one of the reasons this show exists, is so we can broadcast it a few people to a large audience instead of one-on-one. There's a lot of value in that one-on-one conversation because it gets tailored to your specific situation. Unless, it might be that you're doing this. Let's talk broadly. We can get down into the weeds of your specific project.
Yep.
Yeah, and just to add on to that, don't hesitate to call. Those are the fun calls, right?
Yeah, exactly.
Like the calls where things are broken and your infrastructure's down are just as upsetting to us as they are to you. Yep. So we'd much rather you guys call in and let us help you get things set up right.
Really cool, interesting stuff,
and prevent that call.
Yeah, prevent that call from ever having to happen. Yep.
Great. Well, hey, I want to take a real quick break and just say welcome to everybody watching live. I want to give a shout out to Christy and Shrikant for watching on Facebook. Shout out to Faisal, who's tweeting along with us at the Cloud QA hashtag. I got a couple people tweeting along and sharing on Facebook, so we really appreciate that. And again, just to kind of echo what's been said here as we talk about cloud images here at Rackspace, the #1 managed cloud company, where this is what we do. And you mentioned Reese just a couple of minutes ago that every day there's something new about the cloud, right? Yeah. Every single day there's something new, some new technology.
It's not going to stay static. It's going to always be changing.
And you're learning about it all the time. And you're learning about it all the time. We're all learning about it here at Rackspace, and we're sharing information with each other. And we get the opportunity to see so many different customers use that new technology, right? So we're staying on top of it, so you don't have to. So you can just work with your application, and then work with us to put that technology to the best use. So it's definitely out there. Were there any other things that we really want to make sure, like if you're talking to a brand new customer at Rackspace, what are the things that we might not have already discussed that you want every new customer at Rackspace to know about cloud images?
don't uncheck the only charge you if you use install backup, but it's so much better with the file level backup. I guess one thing we haven't really talked about with the cloud backup itself is just kind of the logic that cloud backup has. And that's one thing I really love about cloud backup itself. So at a high level, there's different types of backups. There's a full backup, basically it's going to go in and get the entire file system every single time. And then another one is called a incremental backup. What's really cool about the cloud backup system itself is it's only going to back up data that has actually changed. So if you tell it I want to back up my var www directory, so your web directory itself, it's going to go, the first backup it does is going to be a full backup of that entire directory. The second day it runs, it's going to stat that file system and actually check the MD5 hashes and see if anything has actually changed.
So you add a space to space at the end, a little white space at the end of a file, and it's going to set up a new version of that file, right?
Yes. So then it's only going to back up that one file itself. So it's really cool because it's not going to put a bunch of extra data in cloud files. It's only going to back up the data that's changed, and each one of those backup dates you can actually restore to. So each one of those is a point in time you can restore. You can have up to 30, 60, 90, or indefinite storage amount of time for cloud backup. It can be encrypted to. It can be restored to any server on your account, cross data center. There's a lot of really cool backup, or a lot of functionality that kind of comes with that. And again, we can install that for you by default out of the box. So whenever you go to hit create server, at the very bottom, there's two little checkboxes down there for install monitoring agent and install backup agent.
And those are checked by default, and we recommend that they keep them on.
Yes. I mean, if anything, if you don't want to install backup agent right out of the box, or you're scared about it charging or anything, that's fine. But by minimum, at least install the monitoring agent, because it's just going to help you and help us out in turn.
And just so that we're clear on pricing here, I don't want to steer anybody incorrect. The monitoring is completely free.
Not charged whatsoever.
And highly recommended, because you can see what's going on, and you can also hook that into other systems, right? So PagerDuty, something like that.
Your automation can actually key off the monitoring
that's true.
So there's actually automation out there where you can tie in to specific web hosts. Okay, look at my web nodes. So my web nodes get above X threshold, spin up 5 more, throw them behind load balancer.
And going back to the images, you've probably set up a specific image to use, and then you can even hook some other automation in.
Tie into the SaltMaster too. Okay, my SaltMaster, I saw that 4 new nodes came online. Oh, they're web. Okay, let me go ahead and get everything
all
done
of
with
this
those.
in.
And I mean, excuse me, cloud monitoring is a very mature product too. Like it is easily, you can easily compare it to New Relic or any of those other monitoring products out there for the things that aren't monitored by
control panel. It gets fancy graphs.
Intelligence, cloud intelligence is now the new kind of control panel.
One of the things I wanted to point out is if there's something that cloud intelligence doesn't monitor, you can write a plugin for it. Like there's a whole robust plugin system for the monitoring agent, and there are lots of custom plugins actually in our repositories already that you can use.
Community also is one thing.
And in the community. And some of the examples of those are monitoring Docker containers, monitoring an Elasticsearch cluster, monitoring your Mongo cluster. There are actually already custom plugins written for this in our monitoring agent repos that you can just download and use. One of the things I wanted to talk about that I don't think we've talked a lot about the times not to use cloud images. There's I wanted to talk a little bit about when we should use cloud images.
Lead with that one next time. All right.
There's a reason we still sell this product. So there's a couple really good ones. The very first one is one word: Windows. Windows doesn't have a lot of configuration management options available for it. So in that situation, imaging is really one of the best solutions still available for your orchestration needs.
But you would still recommend using imaging for the system OS level stuff, and then file level backup.
Correct. So like the best practice there would be spin up your Windows server, get the base configuration done, make sure that you have all of your settings the way you want, maybe your base packages installed, and go ahead and image it. From there, test that image, of course, like Drew talked about, make sure that we know it's going to work, make sure that it's reliable, and then we'll use cloud backup or some other backup method to back up all of our dynamic data on a daily basis. It means a little bit more work when you have to restore, because it means that you're going to be restoring that image and then using your backup system to restore the data. So you've got a couple more steps, but time-wise, it's most likely going to be much, much quicker for the restore.
Yeah, that's great. That's great tips there. So you're kind of starting to get into this timeline of how to get things set up. What would you recommend somebody do that's starting from scratch, that's building an application? What type of steps would you recommend as far as when to create that image of your system disk, and when to and what to back up with cloud backup?
So it depends a lot on use cases. We always like to fall back to the main web system, right? That's the majority of what servers are used for. I need to host a website with some dynamic data. So if I'm spinning up a web node, we'll take Linux for an example. Again, Windows is typically a much better use case for imaging. But if I was, I'm sorry, I'm much more familiar with Linux. So if I was going to be using if I was going to be using images and cloud backup as my orchestration method for Linux, most likely my timeline would be that I would spin up my Linux server, get all my users configured, get my SSH keys configured, all of my configurations for how SSH is going to work, install Apache or Nginx or whatever you're going to use, get that configured the way you want, and then leave my web directory empty or leave my web directory in a very minimal state. From there, I'd go ahead and take my image. So we'll have 4 to 5 gig image if we did it right, and then test that image, make sure that it builds out, looks the same way that my server did when I when I imaged it, and then I'd start go ahead and deploying my application. And that would be if I'm doing things well, that would mean going out to Git and cloning down all of our static content, cloning down all of whatever dynamic content we may have that's file based, right? So any image uploads, things like that, we'll go ahead and download out of Git, get my application up and running, and then configure Cloud Backup and get my first backup run.
Great. Couple of questions around portability of images, right? So that's something that a lot of people are interested in, not just having that image available in one data center, but moving them to additional data centers or even different accounts within Rackspace. Can you tell us a little bit about how that might work with moving images around?
Yeah, so we actually have 2 different ways that customers can actually take advantage of that right now. So the easier way, the 2 is sharing images. So there's actually a way you can go through in the control panel, even through the API, where you can actually share a specific image to another customer.
Wow.
And all you really need is that customer's account number. So you basically get your image ID, you go into control panel, you select your image, like, hey, I want to share this image with somebody. So you prompt like, okay, what's that account number? Put in their account number, and then send a request to that customer, and they get to just accept it in their image portal itself. They go through and look at their images, the share probably, and they'll actually see like, oh, hey, look, this image has been shared. Let me go ahead and accept that. Once it's been accepted, they can build out to it.
Great.
However, that can only work for the same region. So if I have an image at DFW, I can only share it to you at DFW also. But there's another functionality that customers can do is where they can actually export the image.
Yeah.
So when they actually export the image, I believe that's only API right now still? Or is it?
Yes,
okay,
that's true.
So it's still only API. So when you export it, you make the call, and it actually will export the VHD into your cloud files. Once it's been exported into cloud files, you can download that locally, do whatever you want with that VHD, or you can take it and then re-upload to another data center. So let's say if I have an image at DFW, I can export it, would export it to DFW, and then I can tell ORD, hey, here's my image at DFW, I need to import this, and then it's going to start the import process. It's all done from cloud files itself. So it exports the image from cloud files and imports it from cloud files also.
And that sounds scary, but we actually have several scripts and guides on how to do that in our community.
Yeah.
Some of those scripts are to the point that it's a one-line operation. You pass it the script, the image that you want to move, what data center you want to move it to, and it takes over and does the rest.
And then in addition to that, right, so we're talking about API things. I want to mention Pitchfork, which is a really neat tool that's created by a racker, Dave Clute, that actually
on our team.
Yeah, he's a great guy. He wrote this tool that is kind of like I call it GUI training wheels for the API, right? So it gives you some examples, and then you can actually even put in your own API key, and it will make the request for you. So you can kind of test out how the API calls work and everything. So that's a great way to use that. Drew, do you have that URL off the top of your head?
Not off the top of my head, but we will put it in the show notes.
Yeah, we will.
I think it's cloud-api.info.
That sounds right.
That
sounds
check
right.
on it.
But yeah, I mean, it's made by a racker. It is
It's getting constant
close
updates
to
too.
yeah. It's being updated very, very frequently. It's a very close to official tool that we have here at Rackspace. And
you mentioned that it's not necessarily like that functionality is not in the control panel, but it is available in the API. Right. And there are people who haven't yet embraced the API and need that functionality. And it's a great way to just get things done that you can't do in the control panel, but that are available. and it's a great way to use them as training wheels. So if you just want to see the way a call would be structured, you can use Pitchfork that way. Not actually make the call through Pitchfork, but just verify your syntax and things like that, which is really useful. And if you go ahead and pass your credentials to Pitchfork, you can make the call from there if you choose. So a couple of different options. You can actually even deploy Pitchfork locally. I believe it's available in GitHub as well.
Yeah, it is.
And that will allow you, if you have additional security concerns or parameters you need to stay within, another option that way.
That's a great point.
One of the things that importing and exporting images is going to inevitably bring up is, I've got this this wild-haired VHD that I pulled from some other environment somewhere in the world, and I just have got to get it into Rackspace. Talk about a couple of the things to consider in that case.
So it definitely works. We have the ability to import external images. There's a couple caveats to that. Again, we're a public cloud, so there's a lot of tools that are baked into our images that make the orchestration of those images much easier. So there's a couple of pieces there. There's a piece of technology called xe-linux-distribution, or on Windows it's called the Citrix tools. What that allows us to do is communicate across a method that Zen server uses, so that we can pass commands back and forth to the server. That sounds scary, but it's really not. There's very limited things that you can do. It's just a messaging protocol.
It's really just for the initial creation of the server itself.
Yeah, exactly. And that protocol is consumed by a separate service that's called Nova Agent on Linux and the Rackspace agent on Windows. And all that agent does is allows us to configure networking at boot time. It allows us to go ahead and push a root password for you, and all of those things that you really need to be able to do when you boot a server. So if you want to import that image, you need to make sure that you have a way to make those packages available. And other than that, most things are able to work. I know that we do have a racker on our team who actually recently was experimenting with getting pfSense imported and was able to make it work. He was able to get the xe Linux distribution and Nova Agent installed and was able to get it into our cloud, and it is running. So
two little caveat, or at least one little caveat I forgot to mention with shared imaging right now, or image export. Does not work for Windows. Only works for Linux right now.
And there's a good reason for that. That's due to licensing.
Right?
We have bulk data center licensing, so we can't really export that and have a way to change that license out for you.
Yeah.
Great.
Yeah, a lot of these caveats are situational. So you can import your image into a Rackspace Cloud account if it's a managed operations account and you have system administrators who are logging in. There are actually a smaller number of images available in those sorts of accounts because we need to be able to ensure our ability to support them, and there's just a lot larger number of distros in the managed infrastructure. But we're also logging into those servers and helping you to do the normal day-to-day administration and management of those servers as well. So if you bring some non-standard image in, if you bring an image from the outside that doesn't have some of those additional functionalities that would be a part of our managed operations, it's going to limit our ability to help you with that specific servers built from that specific image. So things to consider. I mean, will the server function? It should do just fine. Will we be able to support you at the level that we're supporting your other images? No, we won't be able to. We'll do our best, but it's going to be a different environment. So things to consider as you're using this whole suite of tools we've talked about. I think we've covered a decent majority of the normally used tools within our public cloud, but Cloud Images is a linchpin there. You don't get anything stood up if you don't have an image to call. And thanks for clarifying a lot of the lessons learned that we've got and the best practices that we've developed.
Well, and I hope the idea here is that we're in no way able to get all the caveats out there, especially for all the different use cases. We just want to pique your attention, right? And give you an idea that hey, there might be more that you could be doing with images. Give us a call and we'll talk you through it.
Yep.
Real quick before we finish up, we have one open question in our Rackspace community at community.rackspace.com, and I think this is something that you guys can probably help us out with. So we had a customer who was using a Debian 7, a Wheezy image, right, and wanted to update to Jessie did a distribution dash update and or upgrade or whatever it is, and had some issues with that. There are some better kind of best practices to do that instead of just updating from the command line. Can you kind of go through what we would recommend someone do?
Yeah, for distribution upgrades, we don't generally like to do it from inside the OS
Right.
itself and update from one version to the next one via the package manager. Just because from our experience, it seems to cause us a little bit of issues and more headache than good. It will update your packages, but uses a lot of dependencies and other stuff that tends to break when you actually do that. In the long run, it generally makes the system a little bit more unstable than it was previously. What we ideally like to do is actually spin up a new node and then start migrating data and start shifting that workload over there. Again, kind of consuming our other products. Cloud load balancers is the one thing we usually go back to. So one other thing we didn't really mention is all of your nodes should never be a single point of failure. You should always have multi-nodes behind everything. So if you're kind of doing something like this, you should have hopefully 2 or 3 nodes out there, start transitioning to your new nodes, and slowly start bleeding off the old node. So if you want to be at 5 nodes, kill off one node, upgrade to the newest one. Once you have that one working, slowly start bleeding that workload to that newer image itself.
Right.
And that goes back to your immutable infrastructure as well, right? Like if we're truly working from immutable infrastructure, if we're using configuration management, doing an upgrade to a new distribution isn't really an upgrade. It's a couple changes in a config file. It's spending an hour or so to spin up a second environment, test it out, make sure everything works the way I expected it to on this new one.
Always test.
And then a quick deploy to production. So, and really that's going to save you a lot of time over trying to dist upgrade inside the file system and troubleshoot any issues that come up. As far as those issues are concerned, the big ones are, you have to remember that this server is a virtualized server.
Right.
So those distributions, when you're pulling out down those packages from upstream, they're expecting you to be on a hardware file system. So you don't have a lot of those things that it's counting on. Like in some cases, you don't have an MBR if you're using a para-virtualized file system. In all cases, you don't have your own BIOS. So there's those caveats that we work around in our base images that upgrade may not work around.
Yep, absolutely. So thank you. We appreciate you answering that question for our community there. So we'll go ahead and put that information in there for them. So, all right, on that note, hey, thank you guys for joining us today, taking an hour out of your day. You're both busy people, but I think that taking this hour to get this out to as many people as possible is going to be really helpful. I definitely appreciate it. I think we learned a lot of lessons about how images work, some of the best practices for using them, when to use them, when to not use them, and get
the most out of it.
Get the most out of it, and give us a call, right? We're here. We just want to get your attention.
We like supporting people. That's our
We
job.
do, yeah.
We really do.
Yeah, so, you can only ride the slide so many times a day. So come down and give us a call, and we'll be happy to talk it over with you. But anyway, on that note, we'll go ahead and wrap it up and say thanks for watching. We'll see everybody next week, same time, same place. Bye-bye, everybody.
Adios.